Hello students, in this tutorial we're going to discuss the derivative of trigonometric functions. So we'll start from the basic, okay? I'll write it down. Trigonometric functions. Now we have three basic trigonometrical identities, or let me just refer to it as the very common SOHCAHTOA that you know. So which is sine, cos, and tan. So let's use x as our angle of inclination, which is our common theta. So instead of saying sine theta, I will say sine x. So if our y is equivalent to sine x, if our y is equivalent to cos x, if our y is equivalent to tan x. Now, firstly, one of the first thing you need to know is we have standard derivatives and they can be proven. So you can use first principle to prove it, and you can also do some very basic uh, proving to also prove it. So you know that one of the fundamental trigonometric identities that we also have is sine square x plus cos square x equals 1, tan x is equal to sine x over cos x, and the rest. So if our y is equal to sine x, the y dx, when you differentiate sine x, you get cos x. When you differentiate cos x, you get minus sine x. When you differentiate tan x, you get sec square x. So remember, when you say SOHCAHTOA, which are your normal angles, sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, tan theta is opposite over adjacent. So you also have your reciprocal angles, which is co-shacal. So here you have your cosec theta, which is hypotenuse over opposite. Here you have your sec theta, which is your secant, which is hypotenuse over adjacent. Then you have your cotangent, which is your cot theta, which is adjacent over opposite. So most preferable cosec theta is 1 over sine theta, sec theta is 1 over cos theta, cot theta is 1 over tan theta. So that is where the sec is. I'm just trying to explain what sec actually means. So we have different other trigonometric identities. So application of trigonometric functions and differentiation can come in different form. For example, let's assume that we are trying to introduce a kind of function. If we have an example as, let's say, y is equal to sine x raised to power 2, we can use function to differentiate this, because the derivative of this is not going to be cos x squared, because when you say sine x and we say the derivative is cos x, x here is a single function while x squared here is not a single function. So what we can do here is that if you say let u to be equal to x squared, so it means our du dx will give us 2x. So if I use x squared, our y will be equivalent to sine u. So which means the y du will give us cos u. Therefore, the y dx will give us the y du, which is cos u, times the u dx, which is 2x. So everything here will give us 2x cos u, and our u is what? X squared. So it means if you differentiate sine x squared, you're going to get 2x cos x squared. So that's basic application. It can come in the form of product rule. It can come in the form of quotient rule. For example, if you have sine x cos x and you have to differentiate, you use product rule. So when you have y is equal to tan x, even from quotient rule, you can actually solve that. Let's take that as also as an example. If y is equal to tan x, I want to differentiate this. So one of the trigonometric identity that connects tan, sine, and cos is that tan theta, in this case we are using x, is equivalent to sine theta over cos theta. So that's sine x over cos x. So it means that tan x here is the same thing as sine x divided by cos x. So we'll use our quotient rule formula now. Our dy dx will give us v du dx minus u dv dx, everything divided by v squared. So what it means here is that the y dx will give us, our v here is cos x multiplied by the u dx. If you differentiate sine x, you get cos x minus our u. Our u here is sine x times dv dx. If you differentiate cos x, you get minus sine x. So everything here is being divided by v squared. And our v squared is cos x raised to the power of 2, which will give us cos square x. So here the y dx will give us cos x times cos x is cos square x. Minus times minus will give us this plus. Sin x times sin x is sine square x. Everything is being divided by cos square x. So fundamental trigonometric identity, cos square x plus sine square x will give us 1 divided by cos square x. And the reciprocal of cos, don't forget, the reciprocal of cos is what? Sec. So it means that the reciprocal of cos square x will give us sec square x. So and basically that is how this came to life. So basically it can come as an application in different areas, and it depends on how you apply them. So also let's also look at inverse functions of trigonometric functions. Now let's say that y is equivalent to the sine inverse of x, and we have to find the y dx. Now, if our y is equal to sine inverse of x, it means that the sine of y will be equivalent to x. Because if you are solving mathematical questions and you get to a point that sine theta is equal to 0.5, as a math student, what you have to do is that you say theta is equal to arc sine 0.5. So if we are coming from here, if we go backwards, back to this, it means that if y is equal to sine inverse of x, sine y will be equal to x. So now we'll differentiate both sides with respect to what we are going to use to differentiate. We'll differentiate sine y with respect to y. We'll differentiate x with respect to x. So if you differentiate sine y with respect to y, you're going to get cos y. So with respect to y, that's dy. If you differentiate x, you get 1. With respect to x, that's dx. So if you make the y dx the formula, the y dx will give us 1 over cos y. So, but we need to leave the y dx in terms of x because we are differentiating it with respect to x here. So it means that we need to leave this y in terms of x. And the only equation that has y in terms of x is sine y is equal to x. But here we have cos y. So we need to find the trigonometric identity that connects cos y and sine y. And the only trigonometric identity that will satisfy that is sine square y plus cos square y will give us 1, which is the fundamental trigonometric identity. So let's make cos y the zero formula. Here we start with cos square y. Cos square y will give us 1 minus sine square y. So cos square y is the same thing as cos y raised to the power of 2 is equal to 1 minus sine square y. If we find the square root of both sides, cos y will give us the square root of 1 minus sine square y. So what it means here is that our the y dx is equal to 1 over cos y. But now that cos y is the same thing as square root of 1 minus sine square y. So it means that the y dx here will give us 1 divided by the square root of 1 minus sine square y. The y dx will give us 1 over 1. Okay, that's 1 over square root of 1 minus. Now sine square y, since sine y is x, sine square y will give us x squared. So that's why if we differentiate y is equal to the sine inverse of x, the y dx will give you 1 over square root of 1 minus x squared, which is also a standard derivative that you are supposed to know offhand as a calculus student. So now let's also try it for the cos inverse of x, and we'll also try it for the tan inverse of x. So it's just going to be the same approach. So the same approach, if our y is equivalent to our cos inverse of x, it means that cos y will give us x. So therefore, if you differentiate cos y, you get minus sine y with respect to y. If you differentiate x, that will be 1 with respect to x dx. So the y over dx will give us minus 1 over sine y. So we are still using the same trigonometric identity, which is sine square y plus cos square y is equal to 1. And if you make sine y the serial formula, you get the square root of 1 minus cos square y. So what it means here is that the y dx will give us minus 1 over square root of 1 minus cos square y. So this is minus 1 over square root of 1 minus our cos y is x, so therefore cos square y will give us x squared. So the y dx will give us minus 1 over square root of 1 minus x squared for the derivative of the cos inverse of x. Now for the tan inverse of x, same approach. If y is equal to the tan inverse of x, it means that tan y is equivalent to x. So you differentiate both sides, you differentiate tan, you get sec square y with respect to y dy. You differentiate x, you get 1 with respect to x dx. So therefore, the y over dx will give us 1 over sec square y. So the trigonometric identity that connects sec square and tan is 1 plus tan square y is equivalent to sec square y. So instead of writing 1 over sec square y here, I'll write 1 divided by 1 plus tan square y. So this will give us 1 divided by 1 plus, since tan y is equal to x, tan square y will give us x squared. So it means that if you differentiate the tan inverse of x, you are going to get 1 over 1 plus x squared. So basically for this tutorial, this is where we are going to bring this tutorial to an end. See you in the next tutorial.